It was December 2021, a time when most of the world was winding down for the holidays. But for the global cybersecurity community, it was the start of a waking nightmare. It began with a seemingly innocuous discovery in the world of Minecraft, of all places, but quickly snowballed into what many experts described as the single most critical software vulnerability of the last decade. This is the story of Log4Shell, a flaw so deep, so pervasive, and so easy to exploit that it forced the entire internet to hold its breath. To understand Log4Shell, we first have to talk about what it actually was, or rather, where it lived. At the heart of the crisis was a piece of software called Apache Log4j. If you are not a developer, you have probably never heard of it, and that is exactly the point. Log4j is a logging library. Think of it as a specialized notebook for software. Whenever a computer program runs, it needs to keep track of what it is doing, errors, user logins, system messages, everything. Log4j was the industry standard for Java applications to record these events. It was essentially the invisible ink that logged the activity of the modern internet. It was embedded in everything from enterprise cloud servers and government databases to smart devices and consumer apps like iCloud, Steam, and Twitter. The vulnerability, which eventually received the identifier CVE 2021442228, was born out of a feature, not a bug. The developers of Log4j had included a function called JNDI, or Java Naming and Directory Interface. The intention was helpful. It allowed the logging system to fetch data from outside sources to make logs more detailed. However, it created a massive, unforeseen security hole. Specifically, if a user could force the application to log a specifically crafted string of text, they could trick the server into reaching out to an external website controlled by a hacker. Imagine you are a security guard at a building. A guest walks up and hands you a note that says, "Go to this specific address, pick up a package, and bring it inside." If you blindly follow those instructions without checking who sent the note, you have just let a stranger walk inside your building. That was Log4Shell. An attacker could simply send a string like a $sign, followed by a bracket, the word JNDI, a colon, and then a link to their malicious server. When the Log4j library processed that text, it would automatically reach out to the attacker's server, download whatever malicious code was waiting there, and execute it on the victim's machine. This is what we call remote code execution, or RCE, and it is the holy grail for hackers because it gives them full control over a system without needing to physically touch it or even have a password. The sheer scale of the panic was unprecedented. Because Log4j was an open-source library, it was bundled into thousands of different software products. Developers didn't even know they were using it. It wasn't just a matter of patching one single website, it was a matter of finding where this hidden engine was installed across millions of disparate, interconnected systems. When the news broke, IT departments and cybersecurity teams across the globe abandoned their holiday plans. It was an all-hands-on-deck scenario that lasted for weeks. Servers had to be patched, configurations had to be changed, and firewalls had to be updated to block these specific patterns. What made this situation particularly terrifying was how easy it was to exploit. You did not need to be a nation-state hacker with advanced espionage tools. You just needed to be able to send a message to a server. Hackers started scanning the entire internet, firing these strings at every public-facing server they could find, like a blindfolded person. Shooting into a dark room and hoping to hit something. They were searching for unpatched systems, and they found millions of them. The fallout was immediate. We saw ransomware gangs using the exploit to lock up corporate networks, cryptojacking groups using it to turn servers into Bitcoin mining rigs, and state-sponsored actors using it to probe for intelligence. The aftermath of Log4Shell forced a massive reckoning in the tech industry. For years, we had been building our digital world on a foundation of open-source software, but we had been doing it blindly. We were using code written by volunteers, hosted in repositories that weren't always vetted, and relying on dependencies within dependencies that no one fully audited. Log4Shell highlighted the fragility of our modern software supply chain. It exposed the fact that the most critical infrastructure of our civilization was being held together by unmaintained, invisible tools that everyone assumed were secure simply because they had been around for a long time. After the dust settled, the cybersecurity industry went through a significant shift. We saw a new focus on software bill of materials, or SBOMs, which are essentially ingredient lists for software, helping companies track exactly what third-party libraries they are running. We saw a renewed push for funding and supporting open-source maintainers, recognizing that the people keeping the lights on in the digital world were essentially doing it for free in their spare time. Looking back, Log4Shell stands as a reminder of the Internet's interconnectedness. A single line of code, written with the best of intentions, managed to destabilize global digital operations overnight. It was the digital equivalent of a structural flaw in the foundation of every house in a city. It didn't take down the internet, but it proved that it could. It served as a loud, painful wake-up call that in the digital age, complexity is a security risk, and the most dangerous vulnerabilities are often the ones hiding in plain sight, waiting for the wrong person to type the wrong string of characters. Since the crisis, we have become better at monitoring these dependencies, but the shadow of Log4Shell still looms large, a permanent reminder of how one tiny misstep can ripple across the entire connected world.